Hello everyone, and welcome to this Unbound NextGen Virtual HSM interactive demo. Okay, congratulations! The UKC was successfully installed. We have an illustration here of what we've just installed. We have the entry point, which is used for storing key shares, the partner, which is also used for installing key shares, and the auxiliary, which is used as part of the MPC procedures. And we have installed the UKC client. Now, before we start, just at the very high level, the virtual HSM, the Unbound Key Control, is basically a system providing key management and key protection capabilities both on the crypto protection API level, but also on the KMS and key management level, supporting many different key management operations and APIs. So we start by browsing to the admin console, where we can review the different operations that an admin can do, and this will reflect many of the different system features. Browsing into the admin, we have two options. As the virtual HSM has inherent support for multi-tenancy, I can either log in as the root security officer and have a global view on the different tenants, or what we call partitions in our terminology. So there's many different partitions that can exist in the same virtual HSM instance. Or I can log in as a single partition security officer where I manage my own segregated world of keys, clients, users, and so on. Let's browse into the root partition. For the sake of simplicity, we've already included links which will avoid having to type in the username and password. We are logging in as the global security officer. And the first thing that we see is an illustration of the infrastructure that this virtual HSM consists of. Again, we see the entry point, the partner, and the auxiliary. We can take a look on each of the machines. These are the Docker instances, the details of the machine. We can take a look and reveal the fact that the system is healthy. We can control different global system settings. We can review the different certificates that construct the system. We have a PKI embedded into the system. And we can back up the system for the sake of disaster recovery. The most important thing as a global security officer would be to manage the partitions. Partitions are basically a segregated world, segregated from other partitions. So it allows you to have single virtual HSM, a single UKC for your organization, but serving hundreds or more different applications. Each application or team can get its own partition, and once this partition is used by this team, it can only view its specific keys. It can only connect with its specific clients, and so on. Let's create a demo partition. Provide a password for this partition security officer, delegating control over this partition to this security officer. We are creating the first client. And a partition has been created. We now have a new segregate world that can be used for key generation. So these are the main roles that the global security officer would do. Let's log out from here and go back to our demo screen. And now we will log in as a security officer in a single partition where we can do key management. Also, we've already included an easy way in. And once we log into this partition that's used for actual application usage, we see we have some built-in keys that were created using the Docker Bootstrap. We will see how these keys are being used later on. For every key in the system, let's take this for example, I can see the information about the key. This is an elliptic curve key. I can see it as also a certificate of which I can see the serial number. I can see the issuer. This is basically a self-signed certificate. You can see that the subject and issuer are the same, and so on. We also have a more detailed view JSON style that shows the different details of the key. And this key can then be used by multiple sets of APIs that can connect to UKC and use these keys for different purposes. If we want to create a new key, then we can take a look on what types of keys they can create. So we have the full set of common use cryptography, RSA, elliptic curve, EDDSA, which is the Edwards curve latest signing procedure, AES, AES-Civ, which is the NIST approach of doing key wrap with AES. We have XTS, we have PRF, that's a key specifically used for tokenization. We'll see a demo of that later on. We have triple DES, that's used for backward compatibility. We have HMAC, and we have Lima, which is the post-quantum safe encryption scheme. So, already today, with this kind of system, you can do basically any kind of common use crypto. The Suite B, the NIST-certified algorithms, as well as some post-quantum stuff. Let's create a name for this key. A few additional things I can set with each key is: can this key be exportable? By default, we don't allow exporting keys from the UKC, but there are cases where you do want to be able to export. So you can either not export at all, or you can export as plain or wrapped. You can export only wrapped, meaning this would be the option to do secure transfer, but the key can never leave the system in plain. Or we can do wrapped with trusted. Trusted is a specific special feature which allows you to define which keys are allowed to be used to wrap key material which goes out of the system. Another thing we can define that is a significant feature for key management is the automatic key rotation, where we can say that this key needs to be rotated once a year, or maybe provide some custom setting for the key rotation in this case. In this case, we will leave it at 1 year. Another feature is to assign the key some groups. Let's create group 1. So this key will belong to group 1. We will see how groups play a role later on when we discuss access control over keys in the system. So let's create this key. The key is now created. We see it. We can go back and see the info like we've seen in the previous key earlier. We can do a rekey operation. That's basically a key renewal without waiting for the automatic renewal. We can export the key. In this case, as we have defined the key not to be exported, the only thing we can export is the public key. We can delete the key. We can edit the key to modify some of the key attributes, whether it's the name, description, the groups that are assigned, and we can also change the automatic key rotation rules. So that's the tab here on the system, where I can see all my keys and certificates and do management for them. Part of the system is also a secret vault, a complete vault for different secrets that you can use to store a connection string, API keys like any other vault. Then you have REST API and command line to extract the secrets from the systems. The next relevant component is clients. Clients reflect the different application servers that can connect to the system and use it. If a machine is not registered as a client for a partition, it cannot actually use the partition for different crypto operations. This allows you to provide access only to selected application server on the data center. So, let's create a new client. Call it Client 1. I will create the client, and I need to provide this activation code to the administrator of the application server, where it will use to complete the registration process. And then we have a new client of the system. Before we talk about users, let's discuss the roles, which is the way for this system to allow fine-tuning of what a user can and cannot do. By default, the system comes with 2 built-in roles. One is the security officer, which is the role we're using at the moment to do management of the partition. The other one is the user, which is a user of the system, meaning such a role will allow you to do cryptographic operation and some basic key managements, such as creating keys and so on, but will not allow you the overall management of the system. But there are many times where I want to refine the role's definition. So, for example, we would like to either limit what one can do or limit the set of keys one is allowed to use or see or operate. Let's assume we would like someone to be only able to encrypt. So, let's create a role of encryptor. And then we will add permissions. Again, as we recall, we had an option to assign groups to keys. So we can say that in the scope of Group 1, we only allow encryption. So this role allows encryption of keys which are associated to keys in Group 1. Then I can add this role, and once I generate the new user, I can assign it as well. I can, using this tool, create a very fine-tuned access control, which allows specific operations for specific keys. So now I have my roles set up, and I can go and create additional users. I will first create another security officer, which we will use later on in the demo. In terms of authentication, it can be standard or LDAP. In this demo system that is running here, we don't have that configured. So we will keep it standard, provide the password to this user, and create the user. And just for the sake of example, we can create another user that will be just an encryptor. So we have discussed user and roles. We go to the partition configuration. We again see the infrastructure of the system, allowing the admin to verify that indeed the system is healthy. And here's where the admin security officer would set up different settings of the partition. One interesting setting that I'd like to show is the ability to enable Quorum Authorization. So there are different key management operations that we would like to not allow a single security officer to do. A few eyes would be required to authorize the operation, ensuring that malicious activity or erroneous activity will not damage the system. So I can choose for which of the system operations I would like the quorum to apply. Let's take the simple case of delete key as an example, and then say I want at least 2 admins and 2 security officers to approve a key deletion. Now we will save that, and once we go back to keys and certificates and we try to delete the key that we previously created, we get the message that the operation requires a quorum approval, that an approval request has been issued, and you will receive approval shortly. Until then, the key is not yet deleted. If we now go to the Authorize tab, we can see that there is an open request. We can check out the details of that request. We can see who requested, what they are trying to do, the specific details of the key that we are trying to delete, and so on. And this request needs one more approval. It will be pending. The key is not deleted yet. It can still be used until the process is completed. If I now log in as the other security officer that I've previously created and give it some time, I will soon see my authorization tab highlighted. And I need to approve the request for key deletion. I will now approve it. When I log in again as the original requester, I will see in a second that I have things to do. And I have a request for key deletion which is ready for execution. I now have enough approvals. I can now select it and execute the deletion, and when we come back to the keys, we see that this key no longer exists. This kind of workflow and quorum support is available to any operation that you have in the system, whether it's key generation, key import, which we also support, importing keys from a file, etc. This kind of operation is supported for any operation that the virtual HSM supports. You can actually enforce quorum approval for any operation. So this gives a taste of the different things that the system allows you to do as a key management system. Let's log out from these 2 screens and go back to our demo. So, we've gone through the UKC Admin, and now we will start to see some usages of the keys. Not just the management, but also things you can actually do with the system. As I've mentioned, we have plenty of different APIs, starting with a very basic one like PKCS11 and Microsoft KSP and Java JCA and OpenSSL Engine, including KMIP, which is a key management protocol. Basically, the complete set of different integration, interactions, APIs are supported by the system. One of them that is quite cool to see is the tokenization demo. Tokenization is like the king or queen of encryption. It's not only encrypting data, but also keeps the data in the same format that the data was originally in. This is something that is becoming more and more required when you want to encrypt PII, for example, but don't want to change the format or the data type of the data to store it in the same database and still keep the same size. So part of the virtual HSM package or suite is also a tokenization component. You can do tokenization to many different data types, starting from free text, credit card, email, social security number, US phone, and this is just a few examples. Let's take the credit card for example. and we tokenize. We get another credit card. We can see that as each one of these tokens is a credit card number. We can go forward and keep tokenizing these credit cards. And then we can detokenize until we go back to the original value. And here it is. We are back at the original value. And this is true for any of these fields. So, for information like PII, this is all doable using the system. I would just stress that this is a demo site. You can find that the source code of the site is part of the original GitHub where we started our journey, and this is using the API. So, that was tokenization. That's one type of usage of the system. The final thing we will go over is the logs. One of the most important features of such a system would be their ability to provide a complete audit log of whatever crypto operation is being done. We will make everything a bit smaller so we see it on the same line. So this is the audit log of the system. We are now just echoing it to the screen for simplicity, as part of the other demos you can see on our website, and as part of the other integration that you can find on our own integration guide. We also integrate with the different SIEM systems, whether it's the Elk Stack, Splunk, basically every SIEM system which will allow you to review and monitor the different cryptographic and key management activities that are done in your organization. Here, we just echo it to the screen. And if we go back to some key generation, type RSA, name demo2, and we can immediately see in the log the actual command that was executed. So you can see what happened, and you can see that the system was logged in, activated the key, and got the key attributes in order to display it on the screen. If, for example, we would now run the code signing solution. So let's do the JAR file. And we go back to see what's going on. Again, I can see that I was actually signing this file. So you will know every file that was signed on your system with the code signing key. And we can see that the code sign is actually quite extensive. It does different operations. Logins, get attributes of keys. Eventually, we sign the artifact. So you can actually understand every key usage that you have on your organization. Another set of interesting logs are the MPC logs. If you recall, you probably know the entire system. The way it protects keys and protects the crypto procedures is based on MPC. It's based on the fact that the key is split across the different machines. In our case, it's the entry point and the partner. And the crypto log basically reflects the MPC procedures. One way to make sure that no one cheated is to see that we actually have the exact same log, both on the entry point and the partner, in terms of cryptographic operations. Specifically, this was the latest sign operation that was done in order to sign the JAR file. So one way to make sure that no one cheated, that there was no malicious activity in the system, is to make sure that these two logs are exactly the same. And we actually have this feature built into the system. This will be the last thing we show. If we go in here, logging back into the partition where I've done all these activities, then I can go to my server and ask for a download of the crypto logs. Let's say for the last 24 hours. And then when I will look into the logs, I will see all the cryptographic operations that happened, and also a signature of this data. This is a tamper-proof set of logs that the system can generate in order for you to be completely sure what operations happened and that each operation was done in a secure way using MPC. So, we've completed the review of the admin console. We've completed the tokenization demo, we have seen the CLI, and we have reviewed the logs. Now, finally, we can see there is a set of different resources that you can scroll through and read about and get familiar with. All our documentations, the user guide, the developer's guide, everything is available online, is searchable on Google, and so on. Also, most of the things that you see in the documentation, you can actually test it with the system that you've just installed. This is not just including this specific demo. It's a complete system that allows you to review the different system features. This completes our demo. I hope you have enjoyed it, and I hope this was valuable for learning about the Unbound Next Generation HSM. Thanks for watching.